Okay, so this is our project for College Park Scholars, Science and Global Change 101, and we're doing our project on the impacts of climate change on tick-borne diseases. I'm Katie Banovic.
I'm Cagan.
And I'm Martin Haralanov.
Okay, so for some background information, there have been a total of 900 species of tick that have been discovered, and they transmit bacteria, viruses, and parasites. They are separated into two different kinds of ticks, which are either hard ticks or soft ticks. Hard ticks have a hard covering on them, but the soft ticks don't have that. For the transmission cycle of diseases, when we're talking about specifically tick-borne diseases, the mode of transmission is through an animal vector, which is the tick. The portal of entry is like the tick bites. Susceptible hosts would include animals or humans. The infectious agents would be the bacteria, viruses, and parasites. The reservoir is where the virus grows, so that would be within a person or animal's body. And then the portal of exit would be things like lesions. Okay, then for the phenomena, tick-borne diseases, they change distribution based on the vectors and the hosts. It relies on the tick's ability to reproduce and find a mate, and then available hosts, the dispersal of the ticks, and then when peak tick season is. Temperatures influence human activity and exposure to ticks. So as temperatures increase and humans are outside longer, there's an increased risk of being exposed to ticks and tick-borne diseases, such as things like Crimean Congo, hemorrhagic fever, tick-borne encephalitis, Lyme disease, and relapsing fever.
So the main current changes of climate change on tick populations is that droughts in southern habitats are causing ticks to move north, while the black-legged tick, which is otherwise known as a deer tick and responsible for Lyme's disease, is known as a northeastern tick. It actually has previously been present in the south. However, because of warming climates in the south, it's currently migrating north. And as you can see in the reported Lyme disease cases graphic comparing 1996 to 2018, even though there's less dots in the south, there's far more in the northeast and north as well. Ticks are also emerging earlier due to earlier springs happening just because weather's becoming warmer earlier in the year. And STFS in South Korea, which is severe fever with thrombocytopenia, is another tick-based disease that isn't caused by the deer-legged tick, is also causing more of a reemergence, or there's more of an emergence of that. So, yeah.
Moving on to the predicted changes, note that none of these are concrete because it's difficult to predict changes with certain movements like those of the ticks. But first of all, ticks will likely not be able to inhabit the southern US, which means cases for TBE, tick-borne encephalitis, and Lyme disease are going to become super rare in the southern US. And they're going to stay out for longer, and they're going to continue to move into northern latitudes. And on top of that, they're going to move into higher altitudes. And so this was predicted that northern latitudes in the US, we're going to see more ticks. And that has been measured that in the mountains outside of Prague in Czechia, there have been more cases of TBE shown at higher altitudes. And on top of that, increased temperatures have two effects on the actual disease, and that the diseases become A, more contagious, and they develop faster. So springs and summers will be longer. So what else happens when springs and summers are longer? Generally, in Canada, the I scapularis, the deer tick, takes about 3 to 4 years to have a full generational cycle, while in the US, where the temperature is comparatively warmer, tick development cycles are about 2 years. Now, looking at the graph from Daniel et al., the tick activity is measured near an observatory in Prague. And we can see that the first graph is based on ground temperatures, while the other two graphs are based on average and average temperatures in the air. And we can see that there is a correlation between tick activity and temperatures, and the most active that ticks are in the spring, in the summer and autumn, are at the highest temperatures. And so tick activity increases alongside a temperature up to a certain point. And furthermore, according to Daniel et al., the highest infection rates of TBE are shown on mice to be at around 24 degrees Celsius, which is also on this graph when nymphs are most active.
So the main effects on humans are Lyme disease, as that's the main disease that's talked about. Typical symptoms of Lyme disease include or are marked by a red rash with a ring in the center. And that's typically followed a few days after the initial rash with flu-like symptoms, which, if not treated immediately, can cause long-term neurological symptoms such as arthritis. There's also an increased economic burden throughout the world due to tick-borne diseases. For example, in the US in 2019 alone, the burden was 786 million, while in Germany and the Netherlands, it was 40.88 and 23.12 million euros, respectively. However, it's not necessarily all bad, since countries that previously had tick-borne diseases or large spikes of tick-borne diseases are actually at lower risk for infection as they become too warm. However, the warming of those countries also causes other economic burdens, so it's still a net negative.
Okay, and then for the effects on wildlife, the change in distribution of tick hosts. The bird migratory patterns carry ticks to other locations, and the ideal deer habits shift northward, which means ticks will be in new locations. And animals that were not previously exposed to tick-borne disease will now be exposed. And then deer are defined as a keystone species for parasitic development, so they will most likely be treated with arachicides in order to prevent the spread of ticks. And then with predation adaptation, as there are more smaller mammalian hosts in different areas, coyotes and such will come and eat those smaller hosts, and then there will be an increase of vectors because there are a lack of predators. And then for pathogen prevalence, in Norway, there were smaller mammals with more ticks than there were normally. And then here's our bibliography information.
Thank you for watching. Bye.